So let's get started in Blender. All I have is the starting cube, and I'm going to do something similar to what I did in the PowerPoint, because this is going to be the most basic of multi-instance fixture. It's going to be a 1x8 fixture. So I'm going to hit SY and scale my fixture in. And I'm actually going to set it to some accurate measurements here. So let's do 1 meter by 0.3 by 0.4. Let's go 0.4 by 0.2. Okay. So the side that's facing up is going to be our light face. And I'm actually going to shrink this in by a bit. There we go. And so I'm going to go straight to UV editing. And then this is going to be the face. So let's just hit UV unwrap. And then lower this to something that resembles its shape. And then what I can do actually is hit H on this to hide it, and then hit A for all. And then I need to turn this bottom here. Well, I need to turn them all into seams except for one. There we go. And now I can unwrap this, and I get that shape. So let's take that and hit S, shrink it down, and then move it down here. Then we can hit Alt H, and then hit A for all, and we can see that we have no overlapping UVs. That is fine to keep working. Now this is a multi-instance fixture, so we're going to need to divide. We really don't need to divide up the geometry on the export, just on the UV map. But we can simplify that later. This is the simplest version, not necessarily the most performant, just the simplest. One thing that helps with this, if you're working on something more complex, is under base color here, click and go to image texture and go to the internet. Yes, this is what I was searching. And look up a UV test. That's not what I meant. How about a UV map test? There we go. And save something like this one or this one. Save something like this to your computer. And then you're going to use it in Blender when you want to hit open, or when you want to see the... So once you have your image loaded, you're going to click on this side and then hit Z and either 2 or move your mouse down. And now you can see the problem here. So this needs to rotate 90 degrees. You could just type R90. And then it needs to scale opposite of what it's at. So SY, and we'll bring it down into a cube. And then SX, we can scale it up. One easy way to make sure that these coordinates are snapping exactly to the edge so that you can divide these up mathematically is by turning on snapping up here. You hit this little magnet up here, and then be sure to go to the box to the right of it and then turn absolute grid snap on, and then snapping my settings in increment. If absolute grid snap is on, then it'll just increment from where it's at. But if you turn this on, you don't even need to hold control or anything. You just hit, well, I would grab both of them. You just hold G and X, and then it snaps exactly onto the grid. So that's pretty cool, and needs to be done to both sides. And then the last thing, now that we have our clean UV map, we can start changing this geometry a little bit. So with our object selected, we're going to go into edit mode, and then we can go back into modeling. And then hit Control and R, and you'll see this yellow box appear around your thing. So we're going to scroll this up to 7. And then if you've accidentally moved your cursor like I just did, you can just hit escape and then enter. Or click. And then you have it divided up into 8. Once we have it cut up, which fell very conveniently on the slices of the UV test material, we are going to strip away this material. So hit X, and then you need to disconnect this image texture. And then we're going to hit Z, and then press 2 for material preview mode. And press A to select all of your faces. Well, you have to be in face select mode. But select all of your faces, and then we're going to make a material called black. And as you guessed, total 0 values on it. And almost everything is going to be assigned to it. Everything except your first pixel, wherever that falls on your 3D model. Press New. And then we're going to make another texture here where the emission is white. And only this one face is assigned to it. Once we have that, we have our basic primitive model, and we just need to set our settings up to export this both as an image and as a 3D model. So to do that, our render engine needs to be set to cycles. And we need to go into our shading tab. We're not going to do much here. We're going to navigate to our material, and note, don't use this to navigate materials. Click on this circle icon, and then you only need to do this to your lit material. Hit Add, and then search for an image texture. And then you should see this window over here in your shading tab. Go ahead and hit New. And we're going to call this Bake. 1024 pixels is fine. You could even go less than that. Turn your alpha layer off. And then hit OK. And then you're going to reference this image in here. And this is the image that you're going to print to. Bake to. And that should be it. As long as your object is selected and you're in cycles, you can go to bake, and what I like to do is up here turn this samples down to something way simpler, way lower. And then press bake. And if it's doing something, that's good. I have this face here, and I don't know why. This is one of the symptoms of baking. But luckily, I'll solve that at the end, because I want to show you the other way. And that is stuff like this when you're doing baking. It does kind of happen a lot. Just save the image anyway. Image. Let's go to save as. And we want to save this as a resource to bring it in later. So I'm going to make a new folder here. No, it's kind of a mess in here. Call it strip underscore 8. And this is going to be the texture. Now, I want to just do this with you because it's simple and free, and oftentimes takes more time than trying to figure out why certain elements are getting baked in. One probably decent reason is because I didn't remove my light. So that's a good practice, is to remove your point light that's in the scene. And then we can try it again. And it's still there. So yeah, what I'm getting at is it's oftentimes faster to just edit the image. Because what baking it in does is gives us the exact dimensions, and if we have a pretty light up here, it gives us all of those reflections as well. But there's oftentimes we could just edit out the artifacts and it's good to go. Overwrite texture. I feel like that went to this right spot. Okay, so that's good to go. So that's one resource we need. The next, export this as an FBX, and I'll save it in my strip 8 folder and call it Fixture. Then let's export that, and actually one thing that I want to do before I export it, just for good practice, is this face here, restore it back to the black material, and then delete this material. Unable to remove. Oh. There we go. And then we can export. And then in all of that resource gathering, don't forget to save your project file. And we can save that in the directory folder too. And then we're about done in Blender. So let's go over to Unreal and start putting this together. Let me navigate back real quick. All right. So we're going to go to our content drawer, and I have a folder. I would make a folder for your custom fixtures if you're going to be doing this a lot. And then go to new folder. And I'm going to call this strip 8. And then inside here, we're going to want to import our fixtures, and I like to drag and drop. So drop our body in, and it's going to say that it doesn't have a smoothing material. That's fine. And then import our image. Now that we've done that, we can right-click on our content folder and create a new blueprint class called an actor. Let's call it strip a BP underscore. And then open this, and again, I like to drag and drop. So drag your body into the components tab here. And then that should be basically all you need. It already has the material. We're going to rename this shortly. We're going to add here a DMX. And what that is a DMX component that allows us to get a DMX signal from our IP address and apply it to this fixture. So we're going to compile and save, and then I'm going to go in here and start doing this work. One thing we're going to need that we're going to use is a variable. It's going to be called output underscore colors. Important that it's plural there. This is going to be a vector, but it's going to be an array. And so an array is just a stack of single values that are referenced by number. And then the next, to start us off, is a variable called patch. And this is going to be a very specific variable called a DMX fixture patch ref. It's going to default to array after you set that, but this is a single value. So we're going to compile and save that, and then we have to drag our patch in and do a get. And on the event begin play, so as soon as this fixture is spawned into the world or the program begins, we're going to set fixture patch. The DMX object is referencing this DMX object. And then in fixture patch, we're going to drag this out and it's going to convert. So what that's going to do is set this object's fixture patch, or this DMX component's fixture patch, to the patch in the library that we have in here. And then on this DMX tab, we're going to go to on fixture patch received. And then drag out from here. I think. Yeah. That's one way to do it. I kind of like to drag from the more specific option. So from fixture patch, we're going to get normalized matrix cell values. So this is going to fire every time this DMX's fixture patch changes, the one that's set right here. And the cell coordinate, that's right, this pin does not connect. We're actually going to disconnect this. I like to just double click and hit backspace. We're going to do a for each loop here because we're handling an array. And so we're not getting this attribute once, because it doesn't take all of these cell coordinates. It only takes one cell coordinate. And a cell coordinate, if I split this, is just an x and y integer. So we need to execute this 8 times because I have 8 cells. Now luckily, instead of trying, we could, just for reference, we could do a while loop. And then while this is counting down from 8 or from 7 to 0, we iterate over this. But that gets clunky. What I like doing is our output colors is going to be filled with 8 values anyway. So I might as well set those values now. This is 8, even though it goes up 7. Set those values now, and then I have a count of how many cells this fixture has. So then I can just plug this in and say for each of these 8. And then it knows that there's 8. So for each of these 8 output colors, I'm going to iterate over this get normalized matrix cell values. This is a 1x8 fixture. So this cell coordinate X, I just have to remember that I'm adding the range of pixels on the Y coordinate. So X stays at 0, and then Y goes to, Y references the array index. Sorry, you don't have to click on this. Because this is going to scroll from 0 to 7, and so that corresponds with our matrix cell values. From here, what this is referencing right now, which I haven't set up yet, is this DMX library, which I have somewhere in here. One way to access it, one thing I forgot to do, is on this patch variable here, we need to click this eyeball and make it exposed. And then compile and save that. And then when we drag this in, first off, let's kind of zoom into it. We can go to details and find patch here. Now I already have a DMX library, but if you don't, create a new one and then go to it, and we need to set this up. So this is a fixture that I just made. Gonna have to be specific with this one. And so we're going to click new fixture type here. This is going to be LED strip 8. And add mode. It's still going to be a 3-channel mode. And fixture mode, fixture matrix is enabled. And then we go to fixture matrix config. And our Y cells, if we remember, is going to be 8. X cells is still going to stay at 1. Our cell attributes, we're going to have, this is fine, we're going to add more cell attributes here. So let's just do red, green, blue for now. And we'll move on to white and amber cells later. Once this is all saved, we can add it to our fixture patch while we're here. Yeah, that looks correct. And that looks correct. We have 8 cells, 3 channels each, 8, 16, 24. We're good to go here. Let's save this. And then we can go back to our strip. Oh, right. What this was referencing when I pull out of here and type find, it's now going to look for whatever I put here, it's going to look for. So if I put dimmer, that value is not going to change because there's no dimmer here. But there is a red value. Green value. And blue value. Huh? Wow. And these are normalized, so I don't need to divide them by 255. They're also that bright green color, so I know that they're afloat. So what we can do is use this to set our output colors. We can combine all of these by typing make vector and then configure the pins correctly. And then we are almost to setting our output colors, so let's drag out and hit get. And then we need to set array element. And this is what's going to connect to our pin. So this is going to fire 8 times. And one fun way to test if this is firing 8 times is you drag out to a print string, and then you do whatever it is you need to do. And if it fires 8 times, then that's it. So what's going to change though is our array index. This is going to range from 0 to 7. And then the item that we're storing is this value. So this is going to iterate 8 times per every frame this patch changes, which is pretty fast, but it could handle it. Now that we have our output colors, I want to do this in kind of a scalable way. We could always drag out from this pin to continue functionality, but I want to do this in a scalable, clean way. So let's raise this up and hit C and comment this, and I'm going to call this set colors. And so once this is completed, we're going to move on to our next task. And our next task is to take these output colors and push them to the texture that we're about to make. So let's go down here, and I believe I'm logging on some of this. It's set vector parameter value on materials. There. And so the only static mesh we have in our scene is our body, but if you had a yoke or a base, then you'll need to specify that. So body, make sure that that's referenced. And then we're going to set it's going to scan this for, I'm guessing, all of its materials, which in this case is just one. And it's going to look for a parameter with this name. Now, our name, you could, there's 2 ways to do this. If you want to be really pretty, you could type append here and append string, and then you can call this something pretty like colors. But what I learned last time is that you don't need that. All you have to do is reference your array index. So once this is completed, we're going to do, we're not going to go directly to there. We're going to do another for each loop. And once again, we're going to use our output colors, but this time they're going to be full. They're going to be filled with data. And our array index is going to feed into our name. We're going to have to convert that somehow, so probably to string. I would turn on context sensitive, there we go. And then feed this in. And that number will get there somehow. And then the value that we're feeding in is our array element. That is enough to get the information to the material. Let's go to our material now and create what we need. In our material, I'm going to rename this and call it m_strip8. And then edit it. And we have to reference our texture. Now I usually bring textures in this way. I'm not going to do it this time, but I do want to rename this to something like strip8. And then in here, what we're going to make is actually a material function. This is going to be a texture object. And it's somehow new. But yes, we want to use strip8 as our texture object. And then we're going to do some stuff here. We're going to feed this out to a texture sample. And the UVs, going to right click and add a texture coordinate. And then from here, branch off, and on one side, do a mask for red, and then do a mask for green. And that corresponds to the first and second number of the component mask vector, or of the texture coordinate vector, which is a vector that determines this texture object's position, which is important because we need to get this white cell to the other 8 cells. And the reason we don't just drop in 8 more textures is because I think the max that it will allow you to do is 8. So if you want to do any fixture above 8 cells, you can't. So that and storing all those pixels is very inefficient. What I would actually like to do is procedurally generate this square so that I don't have to worry about storing pixel information. But that's for another day. That's going to be one of the upgrades. So what's going to happen next is this is the x-axis here. So I'm going to hit plus on here and add. And then this is going to go out to a parameter. I could just right click this, say promote to parameter, and call this offset. And this is, I'm going to store it out here for a reason. You'll see why later. And then we're going to take these two and we're going to make a vector again, or make a float too. Where's make vector? I'm having a brain fart here. Append vector? Yes. It's not make, it's append. So then once I do that, I can plug this into the UV, and it's going to call this based on my offset. So I can hit apply, and then I like to turn this to a flat image here. And then I run this to my emissive color. And now if I increase this value, that number will change. So that is what we need to shift it along the axis. So what we're going to do is turn this into a material function so we don't have to copy all of this. We're going to copy it once. And then in our content drawer, right click, create material function. This is going to be called, I don't know, set offset, and it's going to be abbreviated by MF. We're going to take all of this and copy it into our new MF set offset. Paste that in, and our goal is to output a texture. The only input we need, so if you right click here and type in, we get function input. The only input we need is a single scalar value ranging from 0 to 1 that gets plugged into this add section here. So once we do that, we can hit save, and then we go back to mstrip8 and can delete all of this and simply use our material function. So if you type in material function call, it'll sometimes bring up the most recent one you made. It might be bringing up the only one in here, but it looks like there's more. And so then this offset parameter goes into your MF's offset. And so we're going to build up one of these. One thing I want to do though is not use a parameter here and just hold 1 and click, and that gives us an integer value. So drag that in, and then this is going to link directly to our emissive color, and we should get a texture out of this. There we go. And then if we increase this value, there we go. Now if it were I could change this to not be a negative value, or I could just it'd be cheapest to do negative values here. So unfortunately that means I gotta hit some extra buttons. So the goal then, I guess for the future, would be to make sure that this falls on the right side of the texture, so that when we add in our values we could simply shift it over to the left. But no, for now, actually what I can do in GIMP is just modify this texture real quick. That way we don't have to add negatives to everywhere. So it shouldn't be too hard to mirror. There we go. And then there, now it's flipped. And we can go back to our material and then change this to a different value. 2. That's a crazy number. But there we go. So then the other thing we have to do is create a bunch of, our base color can stay here, but we can right click and can convert it to a constant. And then the other thing we do need parameters for is we hold 3 and then click, and then right click and convert to parameter. And these are going to be for one of these for each of our pixels. So I haven't yet figured out how to get around this situation because I have to reference the name of something, and that has to be a texture or a parameter. So we're going to need 8 of these, and their names are just going to range 0 through 7 because we have 8 pixels. But we can do that after we multiply all this because there's some other stuff that I would like to set up. So this is a texture that represents this pixel's position, and this represents its intensity and color. So we would want to multiply these together, and then we can almost start. Let's delete this. Once we're set up here, I want to do one thing to the parameter that we're adding in. And instead of hard coding the value in, I want to do it mathematically. So here's what I mean. If we feed this value into our emissive color, it's on pixel position 0. Now if we go to our calculator and divide 1 by 8, we get 0.125. So 0.125, if I plug this in here, increases it exactly 1 pixel, or it should. Now, if your UV map is different, this is when this is really going to come in handy, because it's not too hard to go to each one of these and go, okay, times 2, or 0.125 times 3. But what you could also do is this one's going to be pixel position 0, and then we're going to say times right click. This is going to be times, this is going to be the actual offset amount. So here we're going to put 0.125. And then we're going to say, okay, what's 0 times 0.125? It's 0. So this pixel doesn't move at all, which is how it's supposed to be. But then once we start multiplying these, don't freeze on me. So not too bad. So right, this is 0. This is pixel position 0 times an offset of 0.125, which means it doesn't get offset at all. Now is when we can start multiplying these across. And then here, from the second one down, we tie in an add node. And then with this one, we just say this is pixel position 1. And then what we get when we plug this in is now both of those pixels are filled. And if we change the color of this one, it'll... oh, because these are the same parameters. But if I change the name of this, now these two colors are going to be unique. And that is where we get our pixel mapping capabilities. So let's continue multiplying this. So if you get, this is the most tedious part of the multi-pixels because it relies on parameter names. I'm trying to find a workaround to that. So then two things to do. 0, 0. This has to be 1 and 1. This one's got to be 2. Then its name has to be 2. So let's cue the fast forward. Okay. And now that we've done all that, we have every single cell mapped, and it should respond to pixel map. So let's kind of make this a more neutral color and move on. So now that we have our material set up and ready to take instructions from our blueprint, we are in fact ready to test. All right, so I do have an external DMX source set up because for some reason using it internal, outputting ArtNet from this computer back into this computer wasn't working right now. So I have a rainbow coming in on top of a dimmer curve. And so I'm going to, I don't think our strip 8 is in this outliner right now. It's not. So let's drag and drop it back in, and then we can double click on it to zoom in on it. And it does this sometimes when we reload. It's like there's no static mesh here. I don't know why it does this. That's weird. There's no static mesh in here. Everything else is here. What the? Body. Okay. I don't know how it has no body. But there it is. Everything else is here. I hope. So we have our body. And then we have to go to details and assign our DMX library and make sure that's patched. It is. So then set it to LED strip 8, and then we can do our little trick we learned last time. Patch tool. And we just need to hit address incremental, right? think we just had to do anything in there. And now, let's kind of going on my own here. Yeah, these are now hot. I don't know what's going on, why it's not setting vector parameters. Let's go into play mode just to, oh, it might be upside down. I am in top mode too. Well, my frame rate just, no. Oh, M strip 8, okay. I thought I had to rebuild my material. Alright, that's why, because our material wasn't assigned. There we go. Helps to have that assigned. So now we have our 8-cell pixel bar. And it is outputting. We don't have to go into play mode, but let's just make sure it works in play mode without crashing Unreal. Or what I can do, more efficient, is return this to 0. Now if I hit play, there we go. So it's working. That is, I'm gonna call it right there. And that will be it for the most basic version of an LED strip in RGB. So thank you everybody for watching. Hope you enjoyed, hope you got something out of this, and I'll see you on the next one.